Okay, folks, I'm going to talk. We're going to prepare for the chapter 4 test, which is coming up the week of Thanksgiving, which is November 23rd and 24th. Uh, we'll give you more details on it as the test comes around, but this is a copy of the test review, and I'm going to pause this real quick to change the lighting on it. Okay, I will post this for you in a little bit, but these are terms you need to know. First of all, CPCTC stands for corresponding parts of congruent triangles are congruent. And remember, you can only use that after you have proven the two triangles congruent. Scalene, types of triangles. Scalene means no equal sides. Isosceles is two equal sides. And equilateral is all three sides are equal. Now, if it's equilateral, remember, it's also going to be equiangular. Okay. Now, as far as triangle congruence, there's 5 ways to prove it. We only talked about 4 in class, but I will go ahead and mention the other one for you. First of all, side, side, side. That's where all 3 sides are congruent. Side, angle, side. 2 sides and an angle that is shared by both sides. Angle, side, angle, which is 2 angles and a side that they share in common. And then finally, angle, angle, side. That's where you have 2 angles and a side that they don't share in common. Now the 5th one right here is called HL. It's called the hypotenuse leg. It only works with right triangles. We didn't cover it in class due to time, but I'm going to show you what the diagram looks like, okay? This is the hypotenuse right there, and this is the leg. So hypotenuse leg. So that's one example, and we're not going to, I didn't really spend a whole lot of time on it, but I did want, and I do have an example on here for you, and I'll show you that at the very end of the video, just so you can at least have some experience with it. Okay, now, let's look at the following. We have ourselves a triangle. It's isosceles because we have 2 sides that are congruent. Now, here's what we know. We know that x plus 116 equals 180. So that means that x has to equal 64. Now, because these 2 angles are congruent, then that means that 2z equals x. So 2z equals 64, which means that z equals 32. So z is 32. Now, y right here, y plus 64, because this angle is 64, and this angle is also 64. So 64 plus 64 equals 180. So that means that y plus 128 equals 180. So y equals 52. All right, and I'm going to change that color because, as you know, I don't like orange, but I had to do it anyway because that was the example. Okay, so we got that. All right, now, here's our next one. Well, let's look for the first triangle right here, and I'm going to highlight it right there. Okay, so for that triangle, x plus 90 plus 66 equals 180. So x plus 156 equals 180. So x equals 24. I'm just doing some quick math here for you. All right, now z plus 66 equals 180. So z is going to be 114 degrees. Now, here's one thing that's a little tricky. You got to really be careful here. This right there is an isosceles triangle, so that makes this angle y. So that means that y plus z equals 180. Well, we know z is 114, so it's going to be 2z plus, or excuse me, 2y. Let me fix that. 2y plus 114 equals 180. So 2y equals 66, which makes y equal 33. All right, now those are a couple things. And remember, you can always ask questions. You can email me or you can talk to me in classes. We meet twice a week now. It's a little bit easier to do that. So, all right. Here's what we know. We know this is an isosceles triangle. So here's what I'm going to do for the moment. I got to figure out what these two angles equal. So I've got too many variables here. So I'm going to redo this angle and I'm going to call this, I'm going to redraw this triangle right here. So 64, and we'll call this A. So 64 plus 2A equals 180. So that's going to be 2A equals 116. So when I divide by 2, that means that A equals 58. Okay, so that means that each of these angles right here is 58. So that means that 6C minus 8 equals 58. And 5D plus 3 equals 58. All right, so I know that's kind of confusing, but I had to figure out what each of these angles was before I could set them equal. So here's what I have. So 6C equals 66 because I add 8, so C equals 11. And then I got 5D equals 55, so D equals 11. So both C and D end up equaling 11 here. So I got 11 and 11. So it's amazing how it works out like that. So, all right, now, so save that real quick. Okay, now for the following. This is an example of an equilateral triangle. I know I'm only given two angles, but if I know the two angles here are 60, then this angle also has to be 60 because when I add them all together, they have to equal 180. So that makes these two pairs of sides equal. So that means that 2E minus 8 equals 22, and 5F plus 7 equals 22. So they're both equal. So I subtract 7, I get 5F equals 15, so F equals 3. And for this one, I add 8, so I get 2E equals 30, so E equals 15. All right. Now, I'm doing some kind of quick math here, but you kind of get the idea of how it works, and you see that. So, all right, now, okay. You'll see that we have a couple proofs here. All right, now, we're given three things. We're given that UA, which is right here, is perpendicular to QA. And also we're given that DQ is perpendicular to QA. Now, it doesn't look like it in the diagram. Remember, we trust the data, not the diagram. And we're also given that angle 2 is congruent to angle 3. And we're trying to prove that DA right there is congruent to UQ, which is right there. So you're given all the statements. And that's a good thing. You're given all the statements. So first thing I'm going to write is given. But I also want to prove that these two triangles, triangle QDA, which is right here, I'm going to highlight it in yellow, and AUQ, which is right here in blue. I got to prove that those two triangles are congruent. But before I do that, I got to prove some other stuff here. Now, a moment ago, we stated that UA right here is perpendicular to QA, so it forms a right angle. And we're also stated that that forms a right angle. So now remember, it's a two-step process to prove that the angles are congruent. You have to first state that they have equal measure, which that is by definition of congruence. Perpendicular. I'm sorry, perpendicular. So by definition of perpendicular, the two angles have equal measure. And then we come back and state that they're congruent by the fact that all right angles are congruent. All right. Now, the next part, it says that QA is congruent to itself. Now remember, if two triangles share a common side, then the side is congruent to itself by the reflexive property. So this is congruent by reflexive. And I forgot to draw in the angle, that angle Q or angle 2 is congruent to angle 3. That is part of the given. So now we have enough to prove that the two triangles are congruent by, as you can see, angle, side, angle, angle, side, angle. So angle, side, angle. ASA, angle, side, angle. And then once we prove that the angles are congruent, or triangles are congruent, then we can come back and prove that any remaining parts are congruent, and that would be by CPCTC. CPCTC, corresponding parts of congruent triangles are congruent. All right, now I'm gonna hold off and go to part 2 here in just a moment because I'm just about to run out of space. So I will see you all here in just a couple minutes.